learning.
There are four main types of machine learning algorithms. The choice of the algorithm depends on the type of data in the use case. The two main types of supervised learning that use labeled data are regression and classification. Classification is applied when the output has a finite and discrete value. For example, social media sentiment analysis has three potential outcomes: positive, negative, or neutral. By fitting to the labeled training set, we want to find the most optimal model parameters to predict unknown labels on other objects. If the label is from the limited number of values where these values are unordered, then it's classification. For example, classifying images of dogs and cats into separate labels of dogs and cats. Regression is applied when the output is a continuous number. Given here is an example of a simple regression algorithm. Y equals WX plus V. An example would be the relationship between environmental temperature, Y, and humidity levels, X. If the label is a real number, we call the task regression. For example, finding the actual value of house prices based on features such as location, age building, size, etc. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. It is an equation that describes a line, which represents the relationship between an input x and output y. By finding specific weightage for the input variables called coefficients, b. Predictive modeling is primarily concerned with minimizing system errors or making the most accurate predictions possible at the expense of explainability. We will borrow, reuse, and steal algorithms from many different fields, including statistics, and use them towards these ends. Another popular and easy to understand algorithm is the decision tree. A decision tree is a graphical representation of all the possible solutions to a decision based on a few conditions. It uses predictive models to achieve results. A decision tree is drawn upside down with its root at the top. In the image shown here, the bold text in black represents a condition or internal node based on which the tree splits into branches or edges. The end of the branch that doesn't split anymore is the decision or leave. In this case, whether the employee accepts or rejects a job offer, represented as green oval-shaped boxes. Although a real dataset will have a lot more features, and these will just be a branch in a much bigger tree, we can't ignore the simplicity of this algorithm. The feature importance is clear, and relations can be viewed easily. This methodology is commonly known as learning decision tree from data, and the above tree is known as classification tree, as the target is to classify the jobs as accepted or rejected by an employee. Regression trees are represented in the same manner. They predict continuous values like house prices. In general, decision tree algorithms are referred to as CART, or classification and regression trees. Each node represents a single input variable x and a split point on that variable, assuming the variable is numeric. Naive Bayes is a simple but surprisingly powerful algorithm for predictive modeling. The model comprises two types of probabilities that can be calculated directly from your training data: the probability of each class and the conditional probability for each class given each x value. Once calculated, the probability model can be used to make predictions for new data by using the Bayes theorem. When your data is real valued, it is common to assume a Gaussian distribution, or bell curve, so you can easily estimate these probabilities. Naive Bayes is called naive because it assumes that each input variable is independent. This is a strong assumption and unrealistic for real data nevertheless. However, the technique is very effective on a large range of complex problems. A classic example of naive Bayes would be how our email client classifies our emails as spam or junk and ham or